about or maybe even dealt with what's really going on when hair starts thinning or falling out.
Exactly. We've got some fascinating research to look at today, and we're going to explore the different mechanisms behind it.
We're talking blood flow, hormones, all those physiological bits. And importantly, we're going to connect it to this idea someone asked about Yugami.
Right, this concept of body misalignment, maybe imbalance is a better word, and how that might link to, say, hardening of the scalp's fascia or muscles.
Could that actually reduce blood flow and contribute to hair loss? That's the core question, isn't it? So, our mission today is to unpack all these interconnected factors using the sources we have.
Sounds good.
Oh.
Let's probably start with the big one. Androgenetic alopecia, AGA. It's just so common.
The typical pattern hair loss.
Yeah. And what's characteristic is that it happens in specific areas above this tough sheet of tissue called the Galea ponderotica, the GA. It sits right under your scalp skin.
Okay, the GA. Got it. And that pattern, receding hairline, thinning on top, that's where DHT comes in, dihydrotestosterone.
Precisely. DHT is a really potent androgen, a male hormone, essentially. And for people genetically prone to AGA, it causes those hair follicles, specifically in those AGA zones, to shrink over time. It's called miniaturization.
So the follicles actually get smaller.
They do. And we see in those affected scalp tissues, there's more activity of an enzyme, 5-alpha reductase type 2. That's the enzyme that converts testosterone into DHT.
Okay.
Plus, you find more active androgen receptors and just higher DHT levels overall in those areas.
So more conversion, more places for it to bind. It just amplifies the effect. I think I read something backing this up.
Yeah, there's good evidence. For instance, men who are castrated generally don't develop AGA. Same for men born with a deficiency in that specific 5-alpha reductase enzyme. It points strongly towards androgens being crucial.
Makes sense. And what does the DHT do when it binds to those receptors in the follicle?
It binds to receptors in the dermal papilla cells. They're like the control center at the base of the follicle. And the signal it sends is basically shorten the growth phase, the anagen phase.
So the hair doesn't grow for as long as it should.
Exactly.
Okay.
Each cycle, the growth phase gets a bit shorter.
And over time,
Over time, with these repeated shorter cycles, the follicle itself shrinks, producing hairs that are, progressively shorter and finer. Eventually, they can become almost invisible. That's the pattern loss we see.
right. And people with pattern loss actually have more DHT, more receptors, and more of that enzyme in their scalp.
That's what the research shows, yes. Which is why drugs like finasteride work. They inhibit that 5-alpha reductase enzyme, cutting down DHT production.
Okay, that's a really clear explanation of the hormonal side. But the sources also brought up scalp tension. That sounds different.
It is, and it's a really interesting hypothesis. The idea is that chronic tension in the scalp itself might be a contributing factor, maybe even a driver for AGA.
Tension? Where would that come from?
Well, the hypothesis suggests a couple of things. One is potentially skull bone growth. Not just when you're young, but even subtle growth or changes later in life, like the fusion of the sutures, the lines where skull plates meet under that Galea ponderotica.
So the skull itself changing shape could put pressure on things?
Potentially, yeah.
Yeah.
Pressure on the tiny blood vessels, maybe? The other source could be the muscles connected to that GA sheet.
Muscles, which ones?
Think about the frontalis, your forehead muscle, the occipitalis at the back, temporalis on the sides, even the little muscles around your ears. They all connect to the GA.
Okay.
And here's the link. Androgens, like DHT, influence muscle growth. So particularly in males, you could theorize that higher androgens might lead to these muscles becoming maybe overdeveloped or just chronically tighter, held in a state of tension.
Wow, okay. Hormones affecting muscle tension in the scalp. Is there any evidence for that affecting hair?
There was a pilot study, actually. They injected botulinum toxin Botox into those muscles around the GA in men with AGA.
To relax the muscles.
Exactly. And they saw an 18% increase in hair count over about 48 weeks. It's just a pilot study, mind you, but it strongly suggests that this chronic muscle contraction might really be playing a role.
That's fascinating. An 18% increase is quite something.
It is. And this tension isn't just about squeezing mechanically. It seems it can also kick off inflammation in those tissues where the GA is tight against the skull.
Okay, so tension leads to inflammation,
Yeah.
and where does that take us? The sources mention fibrosis and calcification.
Yes. That chronic tension seems to ramp up signals, including some androgens themselves, that promote fibrosis, basically, too much collagen being laid down, and also calcification, calcium deposits in the tissue.
Like scar tissue forming?
Kind of, yeah. We see something similar in scleroderma, a condition where excess collagen builds up in the skin. If that happens on the scalp, it causes hair loss because the tissue gets damaged.
So the idea is that maybe in AGA, there's a lower level of this fibrosis happening around the follicles.
Precisely. Parafollicular fibrosis, fibrosis around the follicle, and thickening of the dermal sheath, that layer around the follicle. It might be part of what's actively causing the thinning, making the environment hostile for the follicle.
And how does fibrosis affect things like blood supply?
Well, if we look at studies on liver fibrosis, for example, that excess matrix buildup messes with the tiny blood vessels and cuts down nutrient delivery.
Okay.
So applying that to the scalp, this fibrosis could be contributing to the reduced oxygen and nutrient supply that we know exists in balding areas. Studies have actually measured it like 40% lower oxygen levels in balding scalp compared to non-balding.
40% lower.
Yeah. And treatments known to increase blood flow often help hair growth, which kind of supports this idea that pore supply is a real issue.
So fibrosis could choke off the follicle's lifeline, essentially. And you said androgens are involved here too.
It seems likely they play a role upstream, yeah. Because we see the higher 5-alpha reductase, the extra receptors, the higher DHT and AGA tissue, it suggests the androgen activity probably comes before the fibrosis and calcification really set in.
But didn't you say androgens might be protective against calcification in lab studies?
Ah, yes, that's the paradox. In vitro, in the lab dish, the relationship isn't clear. Or sometimes androgens even seem protective. It tells us there must be other factors at play in the body, in vivo.
Okay, so what else is involved?
A key suspect is a signaling molecule called TGF-beta-1, transforming growth factor beta-1.
TGF-beta-1 sounds important.
It really seems to be. It's known to drive both calcification and fibrosis. And in the context of hair, it's thought to promote that parafollicular fibrosis and might even act as a direct stop-growing signal to the follicle.
Okay, so it's bad news for hair. What activates it?
Well, androgen activity can stimulate it. But interestingly, so can reactive oxygen species, ROS, those damaging molecules associated with oxidative stress. And guess what? ROS levels are also higher in AGA-prone tissues.
ROS, oxidative stress. So that's another piece.
And it gets even more connected. Research suggests that when androgens trigger TGF-beta-1 production in those dermal papilla cells, it's actually mediated by ROS.
Whoa, so androgens, bacon, ROS, TGF-beta-1, fibrosis, and maybe less hair growth?
It seems to be a key pathway, yes. It links the hormones to the tissue changes via oxidative stress.
And how does the scalp tension we talked about fit into this ROS picture? Does it connect?
It looks like it does. That physical mechanical tension from the skull changes, or tight muscles can itself increase ROS activity. When muscle cells are stretched, they can produce more ROS.
Physical stretching causes oxidative stress?
In some contexts, yes. Plus, there's this whole field of mechanotransduction, how cells sense and respond to physical forces. It shows that tension in tissues can trigger pro-inflammatory pathways and even increase TGF-beta-1 production directly from a stiff extracellular matrix.
So the physical tension itself could be feeding that whole negative cycle of inflammation and fibrosis.
It certainly looks plausible based on these mechanisms. It adds another layer to the AGA puzzle beyond just hormones.
Okay, this is complex but starting to make sense. Now, let's circle back to that listener question about Yugami, body misalignment. How could that possibly connect to scalp health?
Right. This is where we bridge into ideas perhaps more recognized in Eastern medicine or alternative approaches, but with potential anatomical links. Western science is maybe still catching up here.
So how might it work? Let's think anatomy.
Okay, scalp structure. You've got skin layers, epidermis, dermis of the follicles, and tiny blood vessels. Then subcutaneous tissue with fat and fascia.
Fascia, that connective tissue web that runs everywhere.
Yeah, exactly. That's key here. Below that, the tough scalia ponderotica we mentioned, then the layer covering the bone. The idea with Yugami, or misalignment, is that chronic poor posture or body imbalances could create tension throughout that whole fascial network.
And that tension could reach the scalp.
Potentially, yes. If the fascia in the scalp becomes tight or hardened due to these broader
Like
tensions,
what? Compression.
that's the hypothesis. Hardened fascia could compress those delicate capillaries in the dermis. Less blood flow means less oxygen, fewer nutrients getting to the follicles, and less efficient waste removal.
Okay, that makes mechanical sense. What about muscles?
Tension in neck and head muscles could also play a role. Think about the big muscles in the neck like the sternocleidomastoid, or the scalp muscles themselves, occipitalis, frontalis temporalis. If they're chronically tight due to posture or misalignment,
They could restrict blood flow higher up?
exactly, they could potentially impede flow from major arteries supplying the head and scalp, like the external carotid artery.
So body misalignment, muscle fascia tension, reduced scalp blood flow. That's the proposed chain.
That's the general idea. We can think of a few specific ways it might happen. Direct mechanical compression is one.
Okay.
Another could be effects on the autonomic nervous system, which controls blood vessel constriction and dilation. Misalignment might disrupt that regulation.
Interesting.
Third, the tissue hardening itself might trigger low-level inflammation, further impairing microcirculation. And finally,
Ah.
chronic tension can actually degrade collagen and elastin over time, making tissues and blood vessels less flexible.
So while we might need more direct Western studies, the anatomical pathways seem plausible.
The connections are there, yes. It suggests that things like posture correction and addressing musculoskeletal issues could potentially support better scalp circulation, even if it's not typically considered a primary hair loss treatment in conventional medicine yet.
Fascinating link. Okay, so we've covered DHT, tension, fibrosis, and this potential Y-Yugami connection. What else contributes to hair thinning?
Oh, there are definitely other factors. Stress hormones, for one.
Yeah.
Corticosterone, for example, seems to affect the dermal papilla, those key cells under the follicle.
How?
It stops them producing a molecule called Gas6. And Gas6 is normally a signal needed to activate the follicle's stem cells to kickstart growth.
So stress literally tells the stem cells to stay dormant.
It looks that way, yes. And there's even a tiny muscle, the dermal sheath muscle, associated with the follicle.
A muscle attached to the hair follicle.
Yes. And it can contract, sort of squeeze the follicle, which seems to help initiate the regression phase catagen and might even help move the dermal papilla.
Wow, I never knew there was a muscle involved like that.
It's quite something.
Yeah.
And one source summed things up nicely with what they called the big 8 strikes against hair health.
Okay, what are the big 8?
Let's see. Androgens, like DHT, prostaglandins, certain types can inhibit growth, overactive glucose metabolism in the scalp, bacterial or fungal imbalances.
Like scalp microbiome issues.
Exactly. Then inflammation, fibrosis, which we discussed, general metabolism and circulation problems, and finally, nutritional deficiencies.
That's a comprehensive list. Any examples, like the microbiome one?
Yeah, like an overgrowth of P. acnes bacteria has been linked to more prostaglandin D2, which isn't great for hair and can affect oil production.
Okay. And metabolism.
Issues with how scalp cells handle glucose, problems with managing oxidative stress, redox balance, mitochondrial dysfunction, all these can impact the follicle's energy and health. For example, low levels of a protein called HIF-1 alpha can mess with how follicles use glucose when oxygen is low.
So the cell's basic machinery needs to be working right.
Absolutely. And that low-grade inflammation often seen in balding scalps. It might be linked to those androgen effects, making the scalp more vulnerable, maybe even to mild autoimmune type reactions.
And nutrients are obvious, I guess?
Yes, lack of essential vitamins, minerals, amino acids, they're the building blocks and are needed for all the enzymes to work properly.
We often see lower vitamin D and zinc levels in people with hair loss, for instance.
And one more surprising one you mentioned earlier.
Sleep. Poor sleep quality is actually associated with a higher risk and worse severity of alopecia.
Sleep affects hair loss. That really
Oh.
drives home the holistic connection.
It really does. Everything seems interconnected.
Now, about blood flow you mentioned earlier, it might be a consequence sometimes, not just a cause. That's an important nuance, yeah. Blood flow naturally decreases when a hair follicle enters the resting telogen or regression catagen phase because it kind of disconnects from its main supply.
So the cycle itself causes reduced flow temporarily.
Right. But the flip side is that chronic low oxygen, which comes from persistently poor blood flow, can actually promote that fibrosis we talked about.
Ah, so it's a vicious cycle, potentially. Reduced flow happens during rest, but if flow stays low, it can worsen things like fibrosis, which then further restricts flow.
Exactly. It seems to work both ways, making it tricky to untangle cause and effect sometimes.
Okay. So, given all these complex mechanisms, hormones, tension, fibrosis, inflammation, metabolism, blood flow, what can actually be done? What are the treatment angles?
Well, thinking about that scalp tension idea,
Yeah.
the Botox study points towards muscle relaxation as one potential avenue, though it's not standard practice. And we already know many existing AGA treatments, like minoxidil, work partly by improving blood flow. So, therapies targeting fascia or posture, while needing more research, theoretically aim at that same goal, better circulation.
Makes sense. What about topical products, cosmeceuticals? There's so many out there.
Yeah, the market is huge. The trend now is towards products aiming to tackle several of those big 8 strikes at once.
Using what kind of ingredients?
Often bioactive peptides or plant extracts, things like flavonoids, sterols. You see proprietary blends with names like Ridensil, Capexul, Anisensil, Procapil, and again.
Okay.
They claim various mechanisms inhibiting DHT locally, reducing inflammation, providing antioxidants, stimulating growth factors, improving the follicle environment. Ridensil uses plant glucosides. Capicol has red clover extract and a peptide. Anisensil uses things like licorice root extract and caffeine. Procapil has plant compounds and a peptide, and again uses pea sprout extract.
Lots of different approaches. Do they work?
The key thing really is concentration. For any potential benefit, the amount of the active ingredient in the product needs to be similar to what was used in the studies that showed an effect. Often, off-the-shelf products might not meet that level.
Right, the dose makes the difference. And the established medical treatments.
We touched on them. Finasteride is still a primary way to lower DHT systemically. And minoxidil is a widely used topical, working partly as a vasodilator, improving blood flow, but also stimulating the follicle cells directly.
Okay. Any other approaches mentioned in the sources?
Yes, quite a few are being explored or used in certain contexts. Things like injecting growth factors or platelet-rich plasma, PRP, directly into the scalp, trying to boost regeneration and combat low oxygen.
PRP is quite popular now, isn't it?
It is, yeah. Also, fat grafting or using adipose-derived stem cells is being researched. Low-level laser therapy, LLLT, those caps or combs, has shown some positive results for some people.
Light therapy for hair. Interesting.
hmm And in specific cases, like hormone therapy for transgender women, estrogen might help, potentially partly by reducing scalp tension. Even some antifungal shampoos like ketoconazole are sometimes used off-label, maybe for anti-inflammatory effects, though likely slower than minoxidil.
So a real mix of established and emerging ideas. What about supplements?
Some studies looked at oral supplements. Combinations like L-cysteine, medicinal yeast, pantothenic acid showed some improvement in the percentage of hairs in the growth phase. Omega-3 and 86 fatty acids are also suggested, possibly helping prolong the growth phase, or maybe even inhibiting 5-alpha reductase slightly.
And the vitamins you mentioned.
Right, correcting deficiencies is important. So if someone is low in vitamin D, supplementing might help, especially alongside something like minoxidil. Same for zinc.
And don't forget sleep.
Absolutely. Improving sleep hygiene, just fundamental lifestyle stuff, is linked to better outcomes. It seems basic, but it matters.
It really feels like we've covered a lot of ground here.
Definitely. I think the big takeaway is that hair loss, especially pattern loss, is rarely down to just one thing. It's usually this complex web.
Yeah, an interplay between the DHT hormone signal, the physical environment of the scalp, that tension, the fibrosis then overlaid with potential body-wide influences like misalignment affecting blood flow, plus inflammation, metabolism. It's a lot.
It really is multifactorial,
Yeah.
which means we probably need to think more holistically about maintaining scalp health.
But the upside is understanding all these different pieces, even the speculative ones like Yugami or the exact role of tension, opens up more possibilities for tackling the problem, right? Beyond just blocking DHT.
Exactly. It points towards strategies aimed at improving the overall health and environment of the scalp, better circulation, reducing inflammation, addressing potential tension, alongside the established treatments.
It certainly paints a much richer, more complex picture than maybe people first assume.
It does. And the research keeps evolving. So maybe a final thought for everyone listening. When you think about all these interconnected factors, hormones, tension, blood flow, inflammation, even posture and sleep, what might a truly personalized approach to your own hair and scalp health look like?
Yeah. And what are the big unanswered questions? Where does the research need to go next to really pin down these connections, especially things like the tension and misalignment hypotheses?
Those are great questions. It really highlights how intimately our hair's health is tied to our overall physiology and well-being. It's not just vanity, it's biology.